Game Theory Class 10 Video 3. In this video we're going to introduce the notion of expected value. So first we need to talk about associating payoffs to events. Okay, so again we're still considering probability, so we're considering some experiment, be that experiment flipping a coin or something like that. But we're going to begin considering associating payoffs to events in experiments. So we associate a payoff to events of the sample space. And the way you can think about this is, well, I think it's probably easiest to think about this in terms of gambling. Like, you sort of say, for example, if we're talking about flipping a coin, so flip a coin, the sample space, if you recall, it's very simple, it's just heads and tails, and maybe for some reason there's a rule which says if it's heads then you get +2, and if it's tails then you lose 1. Okay, this is what I mean by associating a payoff to the events. So we associate some sort of numerical payoff to the events, and this is it. And you can think about this in terms of gambling if you want. Like, you bet that it will be heads, and if you're right you get $2, and if you're wrong you lose $1. Okay, so this is the setup which we need before we can talk about expected value. Now let's move on to the definition of expected value. So the expected value is a weighted average of the payoffs weighted by the probability that they occur. So this is quite a complex definition, but all it means is like you take each of those payoffs, you multiply them by the probability that that payoff will actually happen, and then you add up all those numbers. And you should think about expected value as like the average outcome. Or the average payoff. Okay, so the expected value of an experiment with payoffs associated to the events is like the average payoff. And what this means is, you know, like if you do the experiment 1,000 times, how much do you expect to win on average? Okay, so let's do an example of this. Let's do an example where we calculate the expected payoff. So let's start simple. Flip a fair coin, okay? And if you recall, the sample space is just heads and tails. And maybe if it's heads, then you get +2. If tails, then you get -1. The expected value of this experiment is, so we look at this payoff and we multiply it by the probability that it occurs. So that's 2 times the probability that heads happens plus -1 times the probability that tails happens. Okay, I'm doing this step by step to make it easier to follow. So the probability that heads happens, this is a fair coin, so that means it's a 50-50 chance. So that's 2 times 1/2 plus -1 times 1/2, which is 1 plus -1/2, which is 1/2. And that's the answer. Okay, so what this means, qualitatively, what this means is if someone was to offer you this game, like this experiment, and they said, do you want to take part? Like, do you want to play a game where I flip a coin if it's heads, you get $2. If it's tails, you give me $1. Then you should probably do it. Like, because on average, you will win half a dollar on average. So if you played this game 100 times, you expect to win about $50. Not necessarily exactly 50, because you can't be sure. It is random. There is probability. But on average, you expect to win half a dollar per game. So let's do a more complicated example. Okay, so maybe now we roll a fair six-sided die. Okay, and if you recall, the sample space is 1, 2, 3, 4, 5, 6. And maybe the payoff will be the number you roll. The payoff is whatever number you roll. So e.g., if you roll a 4, you get plus $4, plus 4 points, whatever you want. Okay, so the expected payoff for this experiment, the expected value is, so it's going to be, if I write it out very formally, 1 times the probability that you roll a 1, plus 2 times the probability that you roll a 2, plus 3 times the probability that you roll a 3, 4 times the probability that you roll a 4, 5 times the probability that you roll a 5, 6 times the probability that you roll a 6. Okay, which is equal to 1 times the 6th plus 2 times the 6th plus 3 times the 6th plus 4 times the 6th, 5 times the 6th plus 6 times the 6th. They're all a 6th because it's a fair die, right? It's a fair six-sided die. If it wasn't fair, then the probabilities could be different. Okay, so now you either do this in your head or you plug it into a calculator to work out the answer. And if you work it out, you should get that this adds up to 3.5. Okay, so if you're playing a dice game where your payoff is whatever number you roll, then on average you expect to win 3.5 points per roll. Okay, let's do one more example. So how about a bag with balls? Again, 1 red, 2 blue, 3 green. We're going to choose 1 ball at random. And maybe the payoffs are going to be given by this table, which I'm about to draw. So if you choose red, blue, or green, if you choose red, maybe you get +3. If you choose blue, maybe you get +1. And if you choose green, maybe you get -2. Okay, so this is the payoff. The table is just a concise way of writing it down. Then the expected value is going to be given by 3 times the probability of getting a red ball, right? Plus 1 times the probability of getting a blue ball, plus -2 times the probability of getting a green ball. And we actually worked out these probabilities last time, right? There's 1 red ball, so that means the probability of choosing it is 1 in 6. there are 2 blue balls, so that means the probability is 2 in 6. And there are 3 green balls, so the probability is 3 in 6. Okay, and if we simplify this, this is 3/6 plus 2/6 minus 6/6, which is minus 1/6, which is like minus 0.1666 ... something like this. So if you were offered to play this game, then it's not, then maybe you shouldn't play it, because on average you will lose like 17 cents per game if you play this game on average. Okay, that's expected value. That's the end of this video.